Bismillahirrahmanirrahim. Let's discuss one of the very interesting application of dynamical systems related to the dominance of the fittest, dominance of the fittest. So the concept is somehow related to theory of evolution, Darwin Darwin's evolutionary theory. So we will be considering one problem. Uh, let's consider X and Y to be two species. Let's say, X and Y are two species that reproduce exponentially. In other words, I would say that X follows this dynamics and Y follows this dynamics. We also assume something which is A to be greater than B and this is greater than 0. What does this mean? This means that the because A is involved in the model X dot to be equal to X, so this means that X is reproducing itself faster as compared to Y, or we can say that X is fitter than Y because its rate is greater than this one, growth rate, and it is reflected from this inequality. From here we can also conclude that the X share in total population, that is X plus Y, I mean in an atmosphere there are two species X and Y, because the X is fitter than Y, so as time will grow this X will dominate this Y. So X share and X plus Y are the total population will increase as T will go to infinity. So far so good. So if we suppose small x to be the share of x in total population, then it must be given by x small x of t to be equal to capital X of t divided by x plus x of t plus y of t. So this is going to be the share of this x in the total population. Next, we are going to see that what happens to this as time goes to infinity. So my x of t is small f x of t is equal to capital X of t divided by x of t plus y sub t. So that's the fraction of x species in the total population. But we also know that x dot sub of t is equal to a times x. You can solve this simple equation, differential equation, and you will get x of t to be equal to x naught times e power a t, where x naught has to be positive. And also we have something which is the dynamics of y, and it is time derivative of y to be equal to b times y. and from here we can solve and get this over here where y naught is going to be positive. Now I can substitute this value and this value over here and conclude and see what is going to happen to this x of t. So my x of t is equal to, this fellow will become x naught times e to the at divided by x naught times e to the at plus y naught times e to the bt. And you can pull out x naught common in the denominator and you will be end up with this guy over here. This is going to be e to the at and plus y naught divided by x naught e to the bt. X naught gets cancelled with x naught, this guy over here, and then we are left with something that is x of t to be equal to e to the at divided by a power at plus y naught over x naught e to the bt. But we can also take common e to the at in the denominator and we will get this thing over here, e to the at, this is 1 plus y naught over x naught e to the b minus a times t. But then this guy gets cancelled with this and we are left with something that is x of t to be equal to 1 over 1 plus y naught over x naught e to the b minus a times t. Now just apply the limit t goes to infinity. As t goes to infinity, we can see that b minus a is negative because b was less than a. So this guy will move to 0. E to the b minus a times t will move to 0, and this is positive thing, so this is going to be 0, and as a result this guy will become 1 over 1 plus 0, which is 1. What does this mean? So that means that as the time will pass more and more, and another word in long run, and another words after a long time, the x species will dominate y. So everything will be x. In other words, they will dominate y. And at the end of the day, in the atmosphere where x and y were living, you will find x to be surviving and y to be dying out. That was analytical approach. We can also have another approach, uh, that is we can use an alternate approach. Let's see how that goes. Let's do the same problem with another approach. So this is a fraction of the population of x, and this is going to be x plus y. Now I can find out the dynamics of this fraction x. So this is going to be by using quotient rule, which says differentiate u and keep your v same, and then minus keep your u same and differentiate your v, and divide all of this with your v square. So that is going to be equal to x dot x plus x dot y minus x dot minus xy dot divide by x plus y whole square, and this is going to be the dynamics of small x. So this guy gets cancelled with this, and we are left with x dot y minus xy dot divide by x plus y whole square. So x dot is equal to x dot y minus xy dot divide by x plus y whole square. So we are left with this, but we know that x dot is equal to a times x, and this y dot is equal to b times y. All of this divided by x plus y whole squared. So x dot will be equal to, you can perform some algebraic manipulations and show that this is equal to a minus b times x over x plus y times 1 minus x over x plus y. But now this quantity is equal to small x and this also. So that means that my small x of t, time derivative of small x, is going to be a minus b times, this is my x and this is 1 minus x. Now we have seen in the logistic regression model, we can compare this to the logistic regression model. This is exactly the logistic regression model, growth model, population, logistic population growth model, not regression, logistic growth population model. That was equal to x dot to be equal to r times x into 1 minus x over k. So if we define r to be a minus b, which is positive, and k to be 1, then this is nothing but logistic population growth model. So this is, so let me write precisely. So we are left with x dot equal to a minus b times x 1 minus x. So this is logistic population model with r to be equal to a minus b and k to be equal to 1. But for logistic model, we already know that as t goes to infinity, for logistic population growth model, x of t goes to k. But in this case, k is equal to 1. Aha, so that means that with this approach, we can also conclude that as time will increase, or in the long run, x of x will dominate the species y. In other words, for the whole process that we have done for this kind of scenario where there are two species, one has greater reproductive, where one is reproducing exponentially faster than the other one, then at the end of the day, the one that is uh, reproducing faster will dominate the other one. So at the end of the day, the atmosphere will only contain x, not y. This one means 100%. This one means x goes to 1 means that this population x has becomes x plus y. Therefore, x over x plus y has become 1. So that means at the end of the day, you will be left with only this population. This is why we say that there is survival of the fittest. So the one which survives, the one that dominates, and the reproduction or the one that is growing faster will dominate the other one. Thank you. Hopefully we'll be meeting in an interesting video in the next lecture again. Thank you.